Hi, and welcome to Short Little Lessons in Philosophy by philosophynews.com. This series is on introducing logic, and in the first couple of lessons we've been looking at arguments and how to construct arguments. We saw in an earlier lesson that logic consists of premises, a conclusion, and a logical relation between those premises. And so now what we've been doing is digging into the components of premises and conclusions to sort out how we actually construct arguments. So what we saw in an earlier lesson is that logical claims are made up of statements, and statements have a very specific structure. First of all, they're grammatical, which means that they are spoken or written in some language. And within that language, they take the form of a declarative. A declarative is simply a statement of truth, a statement that some situation is true. So if we look at this list of 5 items here, these are all grammatical options, at least in English. People can ask questions, give commands, make explanations, make a performative, I promise, I thee wed. But in logic, only declaratives are used in arguments for premises and conclusions. So carbon is an element, again, is a statement of fact. It's a claim that's made, and those are the types of grammatical structures, utterances, as linguists say, that we use in logical arguments. So to put it simply, this is what we saw earlier. A statement is a sentence, a grammatical sentence, that expresses some truth or possible truth. So not all declaratives in logic have to state an absolute fact. It can state a fact that is possibly true or possibly false. So let's look at some examples. All U.S. citizens live in the U.S. It's a statement of fact. We know that this is false, but someone is claiming it to be a truth. They're claiming it as a truth, an item of truth. The second example, most businesses in Seattle use red carpeting in their office. This is a claim that someone might make. We probably would need to do research to figure out if this is true or false. I suspect it's false, but it's at least being claimed as something that's true about the world. And then finally, Apple has a higher market capitalization than Microsoft. Again, statement of truth. At the time of this recording, it actually is true. That's a fact. But all 3 function in the same way. They're claimed as if they were true. So these are all statements. They're declaratives, and that's how they can function in a logical argument. Now, we run into a problem when we start using statements like these, in that all statements are not created equal. So we have to figure out when we're constructing our arguments which statements we want to use and which statements are the best to use. Now, if you look at the 2 examples here, the 2 sentences, both are declaratives, both make a claim of truth, but they're very different sentences. They're very different grammatical, they have a very different grammatical structure. The first one, the epistemic position of the defense side of the litigation lacks justificatory veracity. Now, when you read or look at that sentence, it's complicated. There's a lot of big words. A lot of people probably don't know what those words mean, or if they do, it just seems like an overly complicated way to express that truth. The second statement, the defendant failed to make her case, that's much simpler. It uses smaller words. It's a shorter sentence. But we might look at these 2, and if you know the meaning of the terms in the first sentence, you would say they generally communicate the same idea. They communicate the same truth. They make this same declarative truth claim. So you might ask yourself, which of these sentences do we want to use in our argument? Are they the same? Does it matter whether we use one or the other? Now, in general, we want to try to communicate more simply. So we might choose the second sentence simply because it is easier to read and easier to understand. But there's something else going on here, and that something else gets us into the next area of our study, and that's to talk about propositions. Propositions are related to statements, and we're going to see in a future lesson how they're related. Before we get into talking about propositions specifically, though, we need to step back and look at metaphysics first. Now, the term metaphysics can sound a little intimidating. It can sound a little woo-woo maybe, a little non-scientific. But in philosophy, it has a very specific meaning. And in order to understand propositions, we're going to take a brief detour and look at some metaphysical concepts that will help us better understand propositions. So when I use the term metaphysics, what do we mean by this idea? Metaphysics just comes from a couple of Greek words. The first meta, which means over or above, and physike, which means matter or physical reality. So what metaphysicians do in philosophy is they study the nature of reality, and really metaphysics does form an important foundation for the study of science, different scientific disciplines. And a lot of the foundational concepts that we use in physics and chemistry and biology and geology are really founded on the work that philosophers do when they articulate metaphysical concepts. So here's some examples. Metaphysicians, philosophers who study metaphysics, study relations, how objects relate to one another. For example, what is the on top of relation, or what is the underneath relation? They study existence. What does it mean to exist and not exist? Have you ever thought about a definition of what it would mean for something to exist? It's a complicated question, and metaphysicians spend their time thinking about that. Causation. How do things in the world affect other things? What is the cause-effect relation? How does it work? Metaphysicians will actually study space and time. They won't study it in the same way that scientists study it, but they will study the relation of space to time. What is the nature of time? Questions like that. And then finally, another example is what does it mean to have a nature? For example, humans have what we call a human nature. Is that something real? What does it mean to possess a human nature? What does it mean for all humans to have the same nature, if that's true? So metaphysics is just the study of those fundamental, foundational concepts about the nature of reality. And we're going to look at some concepts in metaphysics to help us understand better how propositions work and how propositions relate to statements. In order to do this, we're going to look at a very specific example here that I think illustrates what we're talking about. We're going to use the whole notion of properties and look at symbols and how symbols function in other areas of metaphysics, and then we can apply that to our problem when we're talking about propositions. So I'm going to go to my whiteboard here, and I'm going to draw on the screen. Now, if you look at that, what would you say that is? If your answer is that that's a number 7, you'd be wrong. That's actually what we would call a numeral 7. It's a numeral 7 because the figure is actually a representation of something else. For example, I could create 7 dots. Right? We can call that a representation of something else. That's a symbol for something else, just like the figure that I drew is a symbol. I could also draw a little red 7, right? You probably have a calendar on your wall or on your computer that has a bunch of 7s on it. You could take a piece of paper and draw a numeral 7 on it. So the question is, what are all of these symbols representative of? Well, philosophers say they're actually representative of something different. They're symbols, they're expressions of the number 7. And that's why I referred to this earlier as a numeral. The numeral is the symbol of the number. Now you might ask, why bother with this? Why would we bother with making a distinction between a number and a numeral? I'm going to erase these items and illustrate why. Now let's suppose I took my pen here, and I'm going to draw a red 7, and I'm going to make it quite large. Now, philosophers talk about the nature of things in terms of their properties. Their properties are just they're items that are true about something. Okay, so when we look at this red 7 on the screen, and my screen, it's about 5 or 6 inches tall, and obviously it's the color red. So when we start to articulate the 7 on the screen, we would say it has certain properties. Namely, it's red, it's 5 inches tall, it's made up of 1s and 0s. So those are all the properties of the 7 that you're seeing on screen. Okay, so that's a very distinct set of properties that's true of this object that you're looking at. Now let's ask, are those properties true of the number 7? When you think of what the number 7 is would we say that those properties are true? Is the number 7 red? Is the number 7 6 inches tall? Is the number 7 located anywhere, for example? Is the number 7 made up of ones and zeros and electrons and all the rest? Our intuition is that that's not true. Those are not true of the number 7. They're certainly true of this 7 on the screen, but they're not true of the number. So we have at least a hint at a distinction. This 7 on the screen isn't true of what we would call the number, but it does represent that number. So what are some properties of the number 7? Well, we could say that the number 7 is odd. It's an odd number rather than even. We could say that the number 7 is a number that's less than 8 and greater than 6. We could say that the number 7 can stand in mathematical relations like the addition relation or the subtraction relation. Right? So those are all properties that are true of the number 7. Would we say those properties are true of the numeral 7 that you see on screen? Well, it's really hard to see how they would be, right? The numeral 7 can't stand in an addition relation because it's a drawing on the screen. The property red has nothing to do with being even, for example. So metaphysicians talk about this distinction in these terms. They look at the properties of the different objects that we're speaking about. They call out the differences in those properties, and then they say if the properties are different, then we're looking at two different things. And the way we typically talk about it is that this 7 and if we use dots to represent the 7, these are all symbols of something else called the number, the actual number 7. And we can represent the number 7 in a variety of different ways and in a variety of different media. So this distinction is called a distinction between an abstract object, the number, and the representation or the symbol of that abstract object, the numeral. Now, there's a lot of metaphysics involved here. There's a lot of philosophers that disagree with these metaphysics. It's not really important that you accept or even understand all that we're talking about here. What is important is just that you recognize that there is a representation, the symbol, the numeral, and it represents something else, which is the actual object. And that distinction between the symbol and the thing is going to become very important when we talk about statements and propositions. So in the next lesson, we're going to look at propositions and how propositions function relative and in related to statements.